Hello viewers, this video is the second part of VitaminA and E analysis, which represents the details about the instrumental analysis using HPLC. Welcome to Microchem's experiments. We have fragmented the video into 7 steps, like as mobile phase, standard and instrument preparation, VitaminA and E analysis, chromatogram analysis and calculation. We need a balance machine, computerized HPLC system, membrane filtration unit, sonicator bath, HPLC grade methanol, retinyl acetate and tocopherol mixture. Let's prepare the only mobile phase, methanol. Filter 250 ml HPLC grade methanol using 0.45 micrometer membrane filter. Now sonicate and degas the filtered methanol for 10 minutes using the ultrasonicator bath. Mobile phase is now ready. The mobile phase is kept in the B channel of the HPLC system. Now we will prepare standards. Take 10 mg retinyl acetate into a saponification flask and prepare as done during the sample preparation. After this preparation, we will get 10 ml of 1000 ppm VitaminA standard. Video link of the sample preparation is given in the description section. Now pipette 1 ml of 1000 ppm VitaminA standard into a 10 ml volumetric flask and dilute to 10 ml. This will make the 100 ppm VitaminA standard. For the VitaminE standard preparation, use tocopherol mixture and prepare VitaminE standard as done for VitaminA. Let's go for the instrument preparation. Instrumental conditions are shown in the display. So let's set the HPLC system accordingly. This is the HPLC machine connected with the computer. This is auto sampler for the injection of sample. This is the column compartment and the C18 column is connected with it. This is the UV-VIS detector chamber and this is the data acquisition software. Chromatographic conditions are shown in the display. We must ensure these conditions before the analysis of VitaminA and E. Let's make the instrument ready. Turn on the HPLC instrument and open the data acquisition software in the computer. Connect pump module, auto sampler, column oven and detector chamber. We kept the mobile phase in B channel. So, set the flow of B channel as 100%. Set the flow rate at 1 ml per minute. Purge the flow if needed. Wash prime syringe. Wash buffer loop. Wash needle externally. Turn the UV lamp on. Set the wavelength at 325 nanometer for vitamin A. Keep the temperature control off to analyze the sample at ambient temperature. Now we are ready for the VitaminA analysis. Go to Data option. Create a sequence. Save the sequence by the test name. Now we have to create an instrument method for this analysis. Set the runtime at 30 minutes. Write the name of the mobile phase at B channel. Remove the equilibrium stage. Now set the flow rate and flow percent during the runtime. Temperature control is not needed to set. Set the UV wavelength at 325 nanometer if needed. The instrument method is created successfully. Review the instrument method if you want. Click on Save icon and save the instrument method by the test name. Now select the newly created instrument method in the sequence. Now create a processing method. Select the newly created processing method in the sequence. Now select the instrument method and processing method for all the tests in the sequence. Rename the first test name as Standard 100 ppm. Rename the second and third test name as Sample 1 and 2. Delete the third test if you have only one sample to analyze. Rename the position for standard sample 1 kept in the auto sampler. Keep the injection volume at 20 microliter and keep the status idle. Save the sequence. Add the sequence to queue. Go to the queue and click on Ready Check. If the Ready Check result shows successful, then click on Start to start the instrumental analysis of vitamin A. You can see first test status is running. Auto sampler is taking 20 microliter vitamin A standard for the injection. Go to the UV section to watch the online plot. Here we can watch the detector response in live. This is the highest and largest peak at our target time of 2.9 minutes. Let's open the sequence to see the chromatogram. This is the VitaminA 100 ppm standard peak. Peak area and height is shown below. First test is done. Now the second test is running. Autosampler is taking 20 microliter sample solution for the injection. Go to the UV section to watch the online plot of our sample. We are looking for the detector response at 2.9 retention time. We have got a sample peak at 2.9. Let's open the sequence to see the peak in details. This is the peak of vitamin A in our sample, located at the same position of the standard peak. VitaminA analysis is done. Now analyze the vitamin E in the same way. Set the wavelength at 292 nanometer for vitamin E. Now we will analyze the chromatogram of VitaminA analysis. Open the sequence of VitaminA test. You can see we have got the peak of 100 ppm VitaminA standard at 2.9 retention time. Note the area for using it in the calculation. In case of the sample, you can see a peak at the same position of standard, so this peak can also be considered as VitaminA. Note the area of VitaminA peak in sample. Now open the chromatograms of VitaminE analysis. You can see the VitaminE peak at 8.4 retention time. In case of the sample, we found a peak at the same point as standard. So this peak can also be considered as VitaminE. Note the peak area of 100 ppm VitaminE standard. Note also the VitaminE peak area in sample. Let's calculate the VitaminA concentration in our tested sample. Sample weight W is 5.031 grams. Final sample volume V is 10 ml. These two values are imported from the sample preparation video. Let's calculate the dilution factor by solving the equation 1. Now put some values which we have got from the instrument analysis of this video. VitaminA standard concentration C1 is 100 ppm. Area of 100 ppm VitaminA standard A1 is 23832.1.8. Area of VitaminA in the sample A2 is 4306.6. Now solve the equation 2 for the determination of VitaminA concentration in the sample. By solving the equation 2, we got the VitaminA of our tested sample is 3.59 ppm. Let's determine the VitaminE concentration in the same way. No need to change the dilution factor as the sample preparation is same as VitaminA. Finally, we have got the VitaminE in our sample is 30.37 ppm.